All right, lesson 7.2, properties of parallelograms. We are moving on from the idea of the sum of all the angles for all the different polygons. And now we're going to start focusing just on quadrilaterals. So 7.2, properties of parallelograms. We are going to look at proving properties of parallelograms, using properties of parallelograms, and then solving problems involving parallelograms in a coordinate plane. So first, a parallelogram. What is it? So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So in the drawing, they show that we have a parallelogram by labeling all the different parts. So we have our parallel line marks on both sides. We have two sets of arrows on these two sides, and we have one set of arrows on these two sides. So we have both sets of lines parallel. Now, the theorem that we're going to talk about, which it says below, it's on the next slide. Parallelogram opposite sides theorem. This is going to be if a quadrilateral is a parallelogram, then its opposite sides are congruent. In parallelogram opposite angles theorem, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So we know it is a parallelogram based on knowing that the sides are parallel. That's the definition. The theorems give us these extra pieces of information about the parallelograms. Now, you might already know where this is going. We're going back into proofs. So when we did proofs before, again, there's a big importance to know which reason you're using when doing your proofs. So knowing the difference between the definition and these theorems is important when saying what you're going to be doing in that proof. All right, so here we are. We have our first proof. Given PQRS is a parallelogram, prove that these parts are actually congruent. So PQ is congruent to RS, and QR is congruent to SP. Now, we need to have a way of going about this. So first, thinking about what the steps would be. Well, we're going from the fact that we have a parallelogram to the fact that we have these congruent parts. Now, if you look at the diagram, they already have a diagonal drawn in. That diagonal is there as an auxiliary line so that we can show triangle congruence. And then from triangle congruence, we can show all the other parts are congruent. So for this shape, we're going to start off with, we have a parallelogram. That's what's given to us. So again, first statement, PQRS is a parallelogram. Why? It was given. Now, what do we need next? Well, we need that auxiliary line so that we can separate this into triangles. Now, we could have drawn QS, we could have drawn PR. There's more than one way you could have done this. On here, they chose to draw QS. So we're using that idea of the auxiliary line through any 2 points. There's exactly one line. Once you draw that line, now that we have the triangles there, we can use some of our other properties to now show how those two triangles are congruent. So first, using what we're given, we were told it's a parallelogram. So there's a couple of things that always come up in proofs. I said that AIA comes up a lot. I said that reflexive property comes up a lot. And in this proof, both of those come up. Because first off, if it's a parallelogram, by definition, we have parallel lines. So, all right. Because we have these parallel lines, and we now have this auxiliary line drawn in, we're going to have some parts that are going to be congruent. So we had the line drawn, right? Now we have these lines are parallel. Why? Definition of parallelogram. But then, because of that line, we have some congruent angles. Again, since we have parallel lines, this line is going to be acting as a transversal. RQS is going to be congruent to PSQ. And then the same thing on the other side. So we have another set of parallel lines, which gives us a second set of congruent angles. So again, I'm just marking them as we go. We're able to say that both sets are congruent there because of alternate interior angle theorem. Now, once you say that those are congruent, we can move on to finding another piece because we need that magic number of 3. Here, we only have 2. Again, what was that other one that comes up a lot? It's reflexive property. We are sharing that line that we drew in both triangles. So that line that's in the middle, that's going to be congruent to itself, the reflexive property. Now, they switched the order here. They said QS is congruent to SQ. You could have said QS is congruent to QS. That would have been fine as well. The reason why they switched it was so that when we write the statement, they're written in corresponding order. But we have that magic number. We have 3 parts in both triangles. So in each triangle, we have an angle, a side, and another angle. And it's in that order, 2 angles and an included side. So we're able to say now that the triangles are congruent because of angle, side, angle, congruency there. And once you say that the 2 triangles are congruent, then you can say that all the other corresponding pieces are congruent. So they wrote the whole thing out here. Corresponding parts of congruent triangles are congruent, which is also known as CPCTC. So since all the parts in the triangles are congruent, we can write the statement. That was what our proof statement was. The 2 parts PQ and RS are congruent, as well as segments QR and SP. All right, let's go on to the next slide there. Oops. So now, using some of these properties in an example, find the values of X and Y. Well, on X, that's on one of our sides. Y is one of our angles. We're going to do X first. So we have the 2 sides, X minus 4 and 12 are opposite sides. Therefore, those 2 must be congruent. So we're going to set those 2 equal to each other. So we have the X plus 4 is equal to 12. And then we're going to bring the 4 across by subtracting 4, which gives us 8. For the other ones, again, opposite angles are also congruent. So Y and 65 are already opposite angles. So those 2 must be congruent. So we can say that A is congruent to C. Therefore, Y is equal to 65. All right, consecutive interior angle theorem states that if 2 parallel lines are cut by transversal, then the pairs of consecutive interior angles formed are supplementary. A pair of consecutive angles in a parallelogram is like a pair of consecutive interior angles between parallel lines. This similarity suggests parallelogram consecutive angles theorem. So, and we have another property based off of our parallel lines. Again, we call these consecutive interior angles or same side interior angles when we have those angles within a parallelogram themselves. So any pair of consecutive angles are going to be supplementary. So notice how they labeled this. We have Q and P, P and S, S and R and Q. Any one of those 4 sets that I just said are going to be supplementary. So in that diagram, any combination of X and Y end up equaling 180. The other one there, parallelogram diagonals theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So on there, we have QS and PQ are bisecting each other. but not the same length, but they're splitting each other in half. All right. So now they're proving the parallelogram diagonals theorem. So on here, they're showing that they in fact are bisecting each other. Okay? So same as before, we have some auxiliary lines drawn in that are two diagonals. We are going to use the idea of congruent triangles to prove these different pieces are in fact congruent. So the first thing that they started with was the idea that we have a parallelogram, and that was what was given to us. So how do we know that? It was given. Well, since we have a parallelogram, what do we know? We have some parallel lines. So marking on the figure, these two are parallel. That was our definition of a parallelogram. Since it is a parallelogram, and we have these auxiliary lines drawn in, we're able to say that some of these things are congruent. So QPR, and SRP, those two angles are congruent, as well as PQS and RSQ. So now we have two angles that are marked as congruent. We need a third piece. And again, we can't do another angle because AAA doesn't work as a congruency statement. But we do have enough information to say one of these sides is congruent. So using our, let's see, we did this. Using our parallelogram opposite sides theorem that we just proved on the previous slide, we can say that these two are congruent to each other. So PQ is congruent to RS. So now we have three pieces, again, by ASA. We're able to say the two triangles are congruent. And once the triangles are congruent, all of the corresponding pieces are congruent. So QM is congruent to SM. And PM is congruent to RM. Well, now that I have those on there, we can say that M is the bisector of those two lines, because if these two are congruent, M is now our midpoint. And it's a segment bisector. So M bisects QS and PR because of the definition of segment bisector. And that's it. All right, using properties of parallelogram. So as shown, part of the extending arm of a desk lamp is a parallelogram. The angles of the parallelogram change as the lamp is raised and lowered. Find the measure of angle C when measure of angle D is 110. So looking at what we have there on that diagram, C is a consecutive angle to angle D. So what should those be? They should be supplementary. So on here, since they should be supplementary, we can then take the 110, subtract it from 180, and we're left with 70 for that other angle. For example 3, they want us to write a 2-column proof. They said, given that we have these two parallelograms, prove that angle B is congruent to angle F. So this one brings in that other common idea that we're going to use when we do proofs. So we already saw reflexive property being used. We saw alternate interior angles. The third one they said comes up all the time is vertical angles. So on this one, we have the two parallelograms that was given. We also know that the opposite angles of a parallelogram are congruent based on parallel opposite angles theorem. So they're lining up the parts that we have. Let's go ahead and label it on the diagram so we can see. So they said these two are congruent. And they said that these two are congruent. Well, that's great, but wait a minute. We know that these two in the middle are vertical angles. So we should be able to go a step further and say that CDA and EDG are vertical angles. Therefore, they are also congruent. So instead of using, instead of using these, we can go ahead and change those out, because we know that these two are congruent. Therefore, we have the same symbols here. All four of those are now congruent. So using transitive property, if those two angles are congruent to each other, and two of those angles are congruent to each other, so those two in the middle are congruent, then the other two angles, B and F, must be congruent. So again, that was using transitive property. All right. Now, this is the part that gets a little bit more challenging in this section, using parallelograms and coordinate. So find the coordinates of the intersection of the diagonals of parallelogram L, M, and O with vertices at L, and they gave us all the different points there. So we have to think through our different theorems that we just went over and which one would allow us to find coordinates of where these two diagonals intersect. Well, we had our property that said we have a midpoint, right? Or the two bisect each other. Since they bisect each other, that point where they're being bisected is a midpoint. So we can use our midpoint theorem, midpoint equation in order to find that value. Now, it does not matter which set of points you use. So you have two different diagonals. You can either do the diagonal that's going to connect M to O, or the diagonal connecting L and N. Either set would work, but we're going to use the midpoint formula. So here they chose to use O and M. Now, the one thing the book doesn't do in this example, they don't draw the picture, which you technically don't have to, but I would highly recommend drawing it, even if you're just sketching it, just so it's easy to see which points you're using. You don't even have to graph it, but just know these go in order, right? So if we're going in order to visualize which two are across from each other, M and O are across from each other, L and N are across from each other. So again, you could have chose either set. And if you wanted to actually graph it, that's fine too, but you don't have to. Again, when we do midpoint, it's just an average of the x's, average of the y's. So our midpoint here was at 7/2 and 2. Or we could convert that to 3.5 and 2. And there's their drawing. Let me clear this out of the way. So again, they drew the same thing. They showed, if you had to draw it out and graph it, you'd end up with the same idea there, and you'd be able to find that intersection. All right. Using parallelograms in a coordinate plane, 3 vertices are given to us. Find the coordinate of vertex y. So if this is a parallelogram, you have to remember they are given to us in order. So we have to go in the order W, X, Y, Z. So graph the ones that are given to us. So here we have W, X, Y, and Z. So Y has to be somewhere over here, because in order for it to go in the correct order, it'd have to be on that side. Now, you have a couple choices. You can look for the line that would be parallel to WZ, or you could look for the line that's parallel to WX. So they have both of those drawn in here. We are using WX on this slide. So if we find the slope of WX, they make this a little bit more complicated than I really feel like it has to be. But we're going to repeat that slope on the other side in order to find that point. So it's not really that you had to find the slope, but it's more so just finding what that change was. So to go from W to X, we went up 5 and back 2. So then from Z, we went up 5 and back 2, following that same pattern so that our lines would be parallel. And if those two lines are parallel, then we're able to identify our point, which will end up finishing off our parallelogram. And then on this one, if you want to check the other slope as well, so check WZ and WY, then you can do that as well to make sure that those two are also the same slope. Again, we could have done either one in order to find that point, but that's just one way to do it. All right, your assignment is posted on Big Ideas and on Canvas. For this section, 7.2, your assignment is going to be page, let's see, 7.2 is page 593 to 595, numbers 1 through 31 odd. All right, good luck.